Good evening to all. Today we are going to discuss in this lecture about your unicast routing protocols, that is in your communication network subjects. So already we have discussed various routing algorithms. Based on the routing algorithms, I am going to tell you about one of the unicast routing protocol, that is your routing information protocol. So first of all, what are the unicast routing protocols we can discuss? Are some commonly available routing protocols in the internet are routing information protocol which is based on your distance vector algorithm, that is your Bellman code algorithm. Then second one should be the open shortest path first base, which is based on link state routing algorithm, which uses Dijkstra algorithm. And the third one should be the border gateway protocol, which is based on vector path vector algorithm, which uses spanning tree concept for implementation. So these are the unicast routing protocols which is available in the internet. And today we are going to discuss about the protocol. So in this routing information protocol, before going to that, we have to discuss about some of the thing about the autonomous system. What is an autonomous system? So what in this autonomous system means you are having a hierarchical routing. What is this hierarchical routing? From parent to child, grandparents, parents. Likewise, we are dividing. So here this will be based on the back from the backbone, which will be connected to the network service provider, from the service provider to the customer. So here within the network, it is access means we are calling it as the intra-autonomous system, and if it is between two things, it is inter-autonomous system. Okay, so it will be providing a backbone structure from one backbone who will be your soul, that is your organization, the country, and he is going to provide to the several service providers who will be the nothing but the internal service providers such as Airtel, BSNL, like that. Unless we are the customers, we are opting for certain service providers. One will be who's opting for Airtel means another one will be opting for your Airtel, BSNL, like that. It will be going on. So the protocol, routing protocol, running each autonomous system is referred to as intra-autonomous system, and we are categorizing as intra-domain routing protocol or interior gateway protocol. Global routing protocol from one autonomous system to the other autonomous system means it is inter-autonomous system routing protocol. It is inter-domain routing protocol or exterior gateway protocol. So I listed out three protocols. In this, the first two will be your intra-domain, and the last one, that is border gateway protocol, will be coming under the inter-domain routing protocol. Next, we have to discuss something about autonomous system. So each internet service provider is an autonomous system. Okay, so each internal service provider, each will be having some addressing and routers are under its control. So we are this is the autonomous system are not categorized according to the size. They are categorized according to the way they are connected. Okay, so it can be a large or it can be a big. So stop autonomous system has only one connection to other autonomous system. So data traffic can be either initiated or terminated in that stop autonomous system. So that is similar to a point-to-point protocol from one autonomous system to another autonomous system in this step. Multi-code means it will be having more than one connection to other autonomous system, but it does not allow data traffic to pass through it, even though it is having a connection. And the third one should be the transient autonomous system, which is connected to more than one autonomous system and allows the data traffic to pass through it. That is nothing but transient autonomous system. So the routing information protocol, we have to discuss about the first protocol, which is intra-domain routing protocol, which uses your distance vector routing algorithm. Here the metric used should be the hop count. And this router in the protocol basically implements the distance vector routing algorithm, and each will be having an autonomous system. In this autonomous system, within the autonomous system, the routers will be updated with its hop count and the destination. Maximum hop count it can use is of 15. Which means 16 is after if it is going to the hop count it is 16, it is considered as infinity. There is no connection. For this reason, it can be used only in autonomous system in which the diameter of the autonomous system is not more than 15 hops. So hop counts, how we are going to calculate. So for example, we have some 4 networks. In this N1, N2, N3, 4, N4 other autonomous systems. It is having the source as N1 and the N4 will be the source. So first from router 1 to route N4 to reach N4, how many hops there are from router 1 to router 2, router 2 to router 3, then it should be to the network. So how many hops? 3 hops from N to N3 and next to N4. Next for from N2 to N3, then N3 to N4, so 2 hops. And for next finally from N3, that is the router 3, it should be number of hops should be only 1 hop. So, what should be the forwarding table contains? The forwarding table contains all the information about the destination network. That means all what are the nodes or the networks which are connected and through which router it is going to go route and what are the costs. So, for example, for your table 1, example for your table routing 1, router 1 which is connected to N1, N2, N3, N4. So, first we have to list out all the things. Destination network should be N1, N2, N3, N4. So, from N1 to through this router 1, there is no nest router and N2 also no nest router. So only one top. If it is going to connect through N3, so if it is going to connect to N3 from router 1, it has to route from R1 to R2. So the next router should be R2. That is N1 to 2, then from N2 to N3. So total number of hops should be 2. Okay. And from N4, the next router should be R2, but there will be 3 number of hops. Similarly, we have to write the forwarding table for all the number of tables. So how many routers? 3 routers are there. We have to write for all the things. The next forwarding table. So each, for example, we are having 4 networks means definitely 2 will be connected to the neighbor. So 2 will be having the no nest router or immediate connection. Remaining will be going to be cost. So for each and every forwarding table, we have to write this. All routers will be represented in the forwarding table with the information of cost involved. There will be nothing but the hop count. So this RIP, we are telling that we are establishing these protocols, but it will be how it is going to establish these informations by message by using 2 messages. What are the 2 messages? One is the request and another one should be the response. The request message is sent by a router. Without the time, within the time entry, it will be responding with the update message. The response can be either solicited or unsolicited. What is a solicited? It is nothing but immediately after the request message, it is sending only to the answer. But unsolicited response message, on the other hand, is sent periodically every 30 seconds or whenever there is a change in the forwarding table. So that is the request message will be in the form of solicited and response message will be either in the form of solicited or unsolicited. What should be the message format of this routing information protocol? So it is having the commonly how many bits? 32 bits as 1, 2, 3, 4, 5, 6. So 6 into 32 bits totally it will be occupying some more amount of bytes. So COM stands for command. So whether it should be a request message or response message. Version represents the RIP. The RIP is having 2 versions. RIP 1, RIP 2. Normally the RIP 2 is used, so the version number here should be 2. And it is reserved the remaining. What is the family? For this TCP IP, the family, the number value should be represented as 2. And TUG represents the autonomous system information. What are the informations present in the autonomous system will be represented. Okay, the next should be the network address, that is nothing but the destination address, that is the IP address. Next, the subnet mask. Subnet mask is for your prefix length, total amount of packet length. Next, the next hop address, which will be represented in your data table. What is the next hop count? Router. That router's address will be next hop address. And the distance, that is the hop count, number of hops to the destination. So all the last 5 fields, last 4 fields will be having the information about the table entry. That is the forwarding table entry. So after connection is established, bidirectional data transfer will taking place between the client and the server, and after that acknowledgement will be sent both from the data transfer process. So this is about your routing information protocol.